Hello everyone, welcome to my new lesson video. This is the part 2 of my discussion in derivative of a function under the subject differential calculus. I am your teacher, Mr. Mark Anthony B. Laroya. In my previous lesson video, which is the part 1 of my discussion in derivative of a function, I discussed the procedures on how to get the derivatives of the following functions. First one is the derivative of f of x equals ax. Derivative of f of x equals x raised to n. Derivative of f of x equals ax raised to n. The derivative of f of x equals c, or the derivative of a constant. And lastly, the derivative of a polynomial, which is simply getting the derivative of each term. If you haven't seen yet the part 1 of this lesson video, the link can be seen in the description of this video. For this lesson video, I will just be discussing the derivatives of the following. The derivative of a product, or also known as the product rule, and the derivative of a quotient, or also known as quotient rule. Let us now proceed with finding the derivative of a product, or also known as the product rule. So let's say we have a function and it is f of x equals uv, meaning this is a product is in a sense that we have two factors, the u and the v. The derivative of this function, or should we say the derivative of a product, uv, is simply f prime of x is equal to u v prime plus v u prime. So that means in this case, we have to get the derivatives of u and v and then apply it to the formula of the derivative of our function. So let us now find the derivative of this function. Our f of x is equal to quantity x squared minus 2 times the quantity 3x plus 1. So this is the case of finding the derivative of a product wherein our f of x is equal to uv. We have two factors, the u and the v, wherein our u is the binomial x squared minus 2 and the v is the second binomial, which is 3x plus 1. So first things first, we must get the derivative of each factor, the derivative of u and the derivative of v. So for u, which is x squared minus 2, the u prime would be 2x raised to 2 minus 1 minus 0. And for our v prime, that is 3 plus 0. Simplifying the derivatives, u prime will be 2x and v prime will be equal to 3. So substituting the values of u, v, u prime, and v prime to the formula of the derivative of a product, which is u times v prime plus v times u prime, we will have the u, which is x squared minus 2, multiplied by the v prime, which is 3, plus the v, which is 3x plus 1, multiplied by u prime, which is 2x. Simplifying this, our f prime of x will be 3x squared minus 6 plus 6x squared plus 2x. And so, our final answer now would be f prime is equal to 9x squared plus 2x minus 6. So this is the derivative of our function quantity x squared minus 2 times quantity 3x plus 1. We can also solve the derivative of a product in another way. So since these two factors are both binomial, we can use the FOIL method to first simplify this into a polynomial. So f of x will be equal to 3x cubed plus x squared minus 6x minus 2. So this is our new f of x that is simply coming from by using FOIL method for these two factors. And so to get the derivative, we simply get the derivative of a polynomial, that is getting the derivative of each term. And so f prime of x now will be, for 3x cubed, the exponent 3 will be multiplied to the coefficient 3. And then our x will be raised to 3 minus 1 plus 2x raised to 2 minus 1 minus the derivative of 6x is 6, and then minus the derivative of constant 2 is 0. So simplifying this, we will have f prime of x is equal to 9x squared plus 2x minus 6. This is the same derivative that we got using the product rule. Another example, we have f of x is equal to the quantity 4x squared plus 3 times quantity negative 2x minus 1. So we have two factors, u and v. So our u is the first factor, which is 4x squared plus 3. And then our b will be the second factor, negative 2x minus 1. And again, same procedure, we get the derivatives of u and b. So for u, the u prime will be equal to 8x. And for our v prime, that is equal now to negative 2. So substituting the values of u, v, u prime, and v prime to the formula of our derivative of a product, we will now have the u, which is 4x squared plus 3 multiplied by negative 2, which is v prime, plus the v, which is negative 2x plus 1 multiplied by the u prime, 8x. So we will have quantity negative 8x squared minus 16 plus the quantity negative 16x squared minus 8x. So simplifying this, we have to combine like terms. And then we will arrive at the final answer, f prime of x is equal to negative 24x squared minus 8x minus 6. And then again, we can use the FOIL method to simplify this function into a polynomial. We will be having f of x is equal to negative ax cubed minus 6x minus 4x squared minus 3. So as you can see, our polynomial is not arranged based on their exponents or degree. But anyways, it's just the same. We're just simply going to get the derivative of each term. And so we have negative 8 will be multiplied to the exponent of x, which is 3. And then x now will be raised to 3 minus 1. The next term would be this, the one with term x squared. So this is negative or minus 4 multiplied by the exponent of x, which is 2. And then x will be raised to 2 minus 1 minus the derivative of the term 6x is simply 6 minus the derivative of constant 3 is equal to 0. Simplifying this, again, we will have the same answer as the one that we got using the product rule. The f prime of x is equal to negative 24x squared minus 8x minus 6. So let us now proceed with getting the derivative of a quotient, or also known as the quotient rule. From the word itself, quotient meaning the operation is division, so wherein our function f of x is equal to u over v. So u is divided by v, wherein both u and v are functions, and these two are also should be polynomials. So the derivative of a quotient, or the derivative of f of x equals u over v, is f prime of x is equal to v times u prime minus u v prime all over v squared. So again, we have, or it is required that we have to get the u prime and v prime and then apply or plug in all those values to the formula of the derivative of a quotient. So let's say, for example, we have f of x equals x plus 4 all over 2x minus 1. So this is our function, which is actually a rational function. So when we say rational function, we have a function that is in fraction where both numerator and denominator are polynomials. So we are asked to get the derivative of this f of x, and then our numerator, our u, is x plus 4, and our v is 2x minus 1. So first, get the derivative of u. So u prime is simply 1. And for v 2x minus 1, v prime will be equal to 2. So we have now the u, v, the u prime, and the v prime. So we simply plug in all of this to the formula of f prime of x is equal to vu prime minus uv prime all over v squared. So we will have, this is our v 2x minus 1 multiplied by the u prime, which is 1, minus u is x plus 4 multiplied by v prime, which is 2, all over our denominator will become v squared. So our v is 2x minus 1, and it will be raised to 2. And so we will have now in our numerator, on our numerator, we have 2x minus 1 minus 2x minus 8 all over. So using FOIL method, we have 2x minus 1 squared is equal to 4x squared minus 4x plus 1. So we have to simplify this, wherein in our numerator, we can combine like terms. So we can simplify this. Our f prime of x will now become negative 9 all over 4x squared minus 4x plus 1. So this is our derivative of our function x plus 4 all over 2x minus. So let's have another example here. For the derivative of a quotient, find f prime of x of 2x plus 1 all over 2x. So our u, which is the numerator, that is 2x plus 1, and our v is the denominator, which is 2x. So first, we must get the derivatives of u and v, or the u prime and the v prime. U prime will be equal to 2, and for our v prime, that is also equal to 2. So we have now the u, v, u prime, and v prime. So all of this will be used in our formula for the derivative of a quotient. We will have the v 2x multiplied by u prime, which is 2, minus the u, which is 2x plus 1 multiplied by v prime, which is also equal to 2, all over v, which is 2x, will be squared. So 2x squared. So simplifying this, we will be having 4x minus 4x minus 2 all over 4x squared. Simplifying this, it will become negative 2 all over 4x squared. So this can still be simplified because we have negative 2 here and 4. They are both divisible by 2. So our final answer for this one, our f prime of x, will be simply negative 1 all over 2x squared. So this is how we get the derivative of a quotient. So thank you very much for watching this part 2 of my lesson video discussing the derivative of a function. In the next lesson video, the part 3 of this topic about derivative of a function, I will discuss the procedures on how to get the derivative using the chain rule, as well as derivatives of functions involving radicals and exponents, with a little review on laws of exponents. Please don't forget to subscribe and share this video to your friends and classmates. Thank you and God bless.